if we're going to think about how to present our data in a sensible way, then first of all, that will obviously depend on the type of data it is. So first of all, let's define a couple of the terms we're going to be using. So the first distinction I'd like to draw is between continuous data or quantitative, and discrete data or qualitative. So let me say what I mean. So this is things like height or length, kind of the same thing, the mass of something, temperature, time. So all these things are quantitative, by which I mean that they can take kind of an infinite number of values. Depending on the accuracy of measurement. So what do I mean by that? So let's imagine we're measuring the length of something and we're going in meters. So between 0 and 1 meters, we can divide that up. 1, 2, 3. And then for each, so in between, for example, 0.4 and 0.5 meters, again, we can, if we zoom in on that and measure it more accurately, then we can, so this is 0.4, 0.5. So again, now we're zooming in, and you've got 0.45. So let's imagine between 0.4 and 9, 0.45 now. We can zoom in on that. And we can do that forever, each time getting more and more precise. And so between any two measurements at this scale, there are more measurements that we can measure more precisely in between them. So that's what I mean by continuous data. On the other hand, we've got qualitative or discrete data. So that's things like blood type or colour of a flower, or the different alleles of a gene. Either you have them or you don't. Direction of the hair whirl in your hair, we're going to be looking at that in genetics. The degree class you get at the end of your degree. So this type of data falls in one of a few different separate classes, different categories. And note the spelling of discrete here. So discrete with 2 E. So it's discrete spelt that way means kind of a person would be discrete, but that's not what we mean here. Alright, so that's continuous versus discrete types of data. And then the other thing I want to talk about is an independent variable versus a dependent variable. So the independent variable would normally be the one we control. And then we're looking to see what the effect of the changes in that variable are on the dependent variable. So in response to the independent variable. So for example, we might incubate a reaction in different temperatures. So then the temperature would be the independent variable that we're controlling, and then we're looking at, for example, the activity of the enzyme in those different conditions, and that would be our dependent variable.